Okay, so go ahead. This is CA 155. So go ahead and do number 1 and pause the computer here, the video, and do number 1, get your answers for that, and then we'll come back and chat for a little bit. Okay, so hopefully you should know that 1/9 is 0.1 repeating, and so again 2/9 would be 2 1/9, and 3/9 would be 3 1/9, and 4 1/9. So again, unit fraction is so important. But then we come to the end here, and I know we've talked about this before, but this part right here, it says, what can you conclude about 0.9 repeating? So if you look at that, 9/9 is definitely 1. So that means 0.9 repeating has to equal 1. It's not rounded to 1, it is 1. They're exactly the same thing. We can skip this proof if you want to do it, you can, but a third would make 1 whole. But notice 1/3 is what? 0.3 repeating plus 0.3 repeating plus 0.3 repeating, which is 0.9 repeating, which again is another proof that 0.9 repeating is exactly 1. Not rounded to, it is exactly the same. Here's kind of another proof. So we know that this is equal to this. And so if I multiply that by 10, I would get what? So 10n, if n is equal to that, would be what? 9.9 repeating. And then my normal n is just the what? The 0.9 repeating. And so I'm just doing the same thing to both sides. So I get 9n on this side. And then on this side, these cancel, and I get 9. And solve for algebra, I get that n must equal 1. So again, here I'm saying that n is this, right? Right there, n is that. But then I'm also saying n is this. These are exactly equal, not rounded. They're the same number, okay? All right, so we can use that, though, this idea of kind of this proof here, though, to help us rewrite other terminating decimals into fractions, which is a handy little skill. So besides just proving this, we can also look at that. But let's turn the page first, so I'm going to pause it, and let's look at those last 3 numbers on the next page. Okay, so if you look at these, you should be able to write numbers that are identical to these, that are equal. And again, if you have a graphing calculator in high school, this probably happened to you at some point. So 17 would be the same as 16.9 repeating. And again, I know as a teacher, I've had that happen several times, just the way the computer's programmed. So, but I know that's exactly 17. All right, so this one would be what? 23.41, and then again, a 9 repeating, which again, if that ever shows up on your calculator, it's not truly what it looks like. It's 23.42. And then the same thing here. This could be what? 139.7, and then a 9 repeating. And again, it's just because of how the math is calculated, it ends up being that. But again, this is exactly equal. These are not rounded. These are the same. You can see the one. These are identical, and this is identical. And I know that bothers you, but that is reality. All right, we're going to go back and try to, this is just kind of another way to turn things into fractions from repeating decimals, in addition to that other video we had. So we will look at that in just a second. Okay, so let me, I want to get rid of that. That's not what I want up there. Okay, so I'm going to look at, say that you have something like 0.32. and it's repeating. And say you don't know the whole 99 thing, the 999, 999. And so how else could you turn this back in to a fraction? And so what we could do is we could say, well, if I multiply this by 100, so I'm going to let this equal n. if I multiply it by 100, then 100n would get a 32 in front of the decimal place. And it would get that repeating decimal really nicely lined up after the decimal place. And so then my original n was just the after the decimal point part. And so if I subtract these, then here I get 99. And again, we should know that because we know what 99 does. And then if I subtract these, the repeating decimal cancels, and I just get the 32. And so then divide both sides by 99. And notice, similar to that other video, you can see how that converts it into a nice fraction. And so, again, repeating decimals are rational numbers. They make a ratio. They are a fraction. They're not irrational numbers, which are like, say, the square root of 11. Square root of 11 goes on forever. It never ends. It never has a pattern. It is an irrational number, where repeating decimals can actually be turned into fractions, which are rational because they have a ratio in them. So if I can spell here, so it is a rational number because you can make it into a ratio. So any fraction is rational. Any non-terminating, non-repeating decimal would be irrational. But again, this is another method which is kind of nice to convert them. All right, let's go. Where's my video recorder here? Let me see if I can bring that up. Okay, so let's look at this example, and I had to edit a little bit there, so hopefully it wasn't too wonky for you. All right, so again, just multiplying this by 10. The problem is this is 3.46666666. So the 4 is not repeating, just the 6. So if we're going to use the n idea, we can, again, scale both sides here to make it equivalent. So multiply by 10, multiply by 10. And I'm going to multiply by 100. Our goal is to get the repeating decimal part to line up. So if I multiply by 100, this would be what? 346. And then just the 6 repeats. And so your goal is to get the repeating part to subtract. And so if you notice right here, these two will do that. So I'm going to take 346.6 repeating, which is equal to 100 times n. And then I'm going to use my 34.6 repeating, which equals my 10n. And again, I'm using those two because when I do those and I subtract, the repeating decimals subtract out, which is your goal, is to get rid of the repeating part. So I get 90n, and then over here, these cancel out, so I get a 2 and a 1 and a 3. So I get 312. Divide both sides by 90. And so this is my fraction now. It is not reduced because if you look at that and you remember your divisibility rules, so if you add up the digits, 3, 1, and 2 adds up to 6. So I know that I can reduce this by dividing both by 3. So that would be 30. And let's see, that would be what? Is that 104? And then that probably might be about the best I can get. So anyway, but again, if you want to check your answer, you could take 312, the original, divided by 9d, which is correct. It gives us the 3.4 and then just the 6 repeating. Now again, remember we would have separated this into 3 and 4 tenths and 6 over 99 and got a common denominator of 990, and we would have done all that and simplified and so forth. But you can also use this nice little trick, I guess, and do kind of some scaling up and scaling down so that you can subtract and then get a fraction that works for you. And again, on my math lab, they might want the reduced one. So again, knowing your divisibility rules might help you with simplifying. All right, that's another option to convert things into fractions that are repeating.